Okay, good day, folks. Welcome to my YouTube channel. Today we presenting the topic that is called momentum, and we're going to look at the change in momentum. Guys, welcome to my channel and happy New Year! Compliments of the season. It's good to see you back on my channel, and let's cut the chase. What is momentum? In a nutshell, when we talk about an object that has a motion, a moving object, we call that object has a momentum. But in terms of the exam guideline, grade 12s, the momentum, you have to define it according to the exam guideline. And the exam guideline, it says it is the product of object's mass and velocity. When we talk about the product, from its formula, a product it's multiplication between two variables. So it's a product of mass and its velocity. So the object that is moving, the momentum, it's m times v. And the momentum, guys, it's p, it's a small letter p, and its formula, it's p is equal to mass times velocity. So the units for the momentum, it's kg meter per second. Another thing that is important about the momentum is a vector quantity. That means it has both magnitude and direction. So the momentum of an object, it must have the direction because it's the vector. And another thing, there's a relationship between these quantities. So if we look at one relationship, let's say if we look at the relationship between the momentum and the velocity, so we should keep the mass constant. So the momentum and the velocity are directly proportional. So what do we mean about that? If we increase the velocity, the momentum will increase. If we double the velocity, the momentum will be double. If we half the velocity, the momentum will be halved. So that's a direct proportionality while the mass is constant. Now let's look at the example here. The example here that I have Sia Kolisi, and everybody knows Sia Kolisi, and he's running at a speed of 3 meters per second. And his mass is 105 kg, 105 kg. So he increases his speed from 3 meters per second to 8 meters per second. So his speed here, it's going to be constant. It does not change. So what does not change? It's a what? It's a control variable. So his mass does not change. And what has changed here? Remember, what has been changed, guys, here we call it's an independent variable. So the velocity here, it's an independent variable, is the one that is changed from 3 to 8. So the independent variable here, it's going to be the speed or the velocity. It's going to be the velocity in this case. And then the momentum now will depend by changing the velocity. Increasing the velocity will increase the momentum. So we increase the velocity here, so the momentum will depend on the velocity. So the dependent variable here, it's going to be the momentum. So graphically, guys, this relationship between mass and the momentum and the velocity. So here it's going to be momentum in kg meter per second, and here it's the velocity. It's the velocity is meter per second. Once, guys, the two variables, they have a direct relationship. So the graph, it's going to be a straight line graph that cuts through the origin. Zero velocity, zero momentum. Increasing velocity, there will be an increase in momentum. Increase in velocity, increase in momentum, increase in velocity, increase in momentum. So it's going to be a straight line that cuts through the origin. The graph is going to be like that, guys. Now let's look at another example here. The example here, we have two rugby players. We have Cheslin Colby and Sia Kolisi. Now we're going to look at the relationship between the momentum and the mass while the velocity is constant. Now the relationship between the momentum and the mass is directly proportional. Greater mass, greater momentum. Increasing mass, increasing momentum. Doubling the mass, you double the momentum. They have a direct relationship as well. Now let's look at the two players. They have the same speed. When they have the same speed, all right, when they have the same speed, but they have different masses. So that simply means that they're going to have different momentum. You can even prove it by calculation. They have different momentum, but the difference between there, it's the masses. So the one with a different mass will have a different momentum, greater mass, greater momentum, while the speed is kept constant. So we'll say if the speed is kept constant here, so we'll say the control variable, it's the velocity, which is the speed, and the independent variable is the one that is different between the two, is the what? Is the mass. The independent variable. And the dependent variable here, it's going to be the momentum. Momentum, it depends on the mass in this case. So graphically here we have the momentum. I should put the units there. And here we're going to have the mass. The mass of them, it's in kilograms, and the graph, it's a straight line. Zero mass, zero momentum, and then while the speed is constant, so it will be a graph like this. It's a straight line, just like the previous one. Let's look at the example of calculating momentum. It says 1000 kg car is moving at 10 meters per second. Here's the car, and we can see the direction. We choose that direction as positive. Let's say that direction is to the right as positive, or east, whether whatever that direction you want to choose. We choose to the right as positive and to the left as negative. It says calculate the momentum. So what we have the mass and we have the velocity, right? So guys, another thing that is important about the momentum, it's in the direction of the velocity always. So this velocity is going to the right in a positive direction, and also the momentum is going to go to the right in the positive direction. So now calculating the momentum, there we write the formula: momentum is equal to mv, and then we substitute. We have the mass is 1000, and then we multiply by 10, and of course it's going to be 10,000 what? Kg meter per second. Meter per second to which direction? To the right. That's the momentum. That's how you calculate momentum. Let's look at the following question. It says Lebu with a mass of what? 50 kg. That's the mass. It's very important to note your data. Running in a straight road with a momentum of what? 1500. So this is the momentum. It's P. And then we choose Lebu's direction as positive. She's going to the right. And now the question, it says calculate its velocity. It's her velocity. So we use the formula. We want V. We use the formula that P is equal to mv, and then and then we substitute what we have. The momentum will be positive because she's going in the positive direction, and her momentum will be positive. So we put the 1500, and the mass is what? Is 50, and we're looking for V. And then what we're going to do there, we're going to divide the 1500 by 50. So we'll say we'll divide by 50 both sides, and then so the velocity is going to be what? 30 meters per second, and the direction is to the right. That's how you calculate the momentum. Change in momentum. When an object changes its velocity. Um, when an object changes velocity, it's accelerating or decelerating. Its momentum will also change. So there's a change in momentum once there's a change in velocity. So changing in velocity, it can speed up or slow down. Right? Let's take an example. When you throw a ball towards the wall, you throw it with a different velocity. With a different velocity, this is the wall, and then you throw a ball. That velocity will be an initial velocity. So when it um, hit the wall and it goes back with a different velocity. That's the final velocity. So there's a change in these velocities. So the collision of the ball with the wall, it changes its velocity and it changes the direction as well. So there will change in velocity and then change in momentum. So once there's a change in velocity, there's a change in momentum, right? Now the formula for a change in momentum, it's delta p for momentum. It's momentum final minus the momentum initial. We know the formula of a momentum, it's mv, so it's going to be mv final minus mv initial. So you can shorten and make m as a as a what, okay, mvf minus mv initial, um, as a common factor. Right, let's look at an example. The example here, it says a 10 gram and 100 gram of a tennis ball. So we change that mess and we divide by 1000. So it's going to be, when you divide by 1000, it's going to be 0.1 kg, right? So a 0.1 kg tennis ball strikes the wall with a velocity of 13 meters per second, as you see in the picture here. So the 13 is the initial velocity, meters per second, and we choose towards the wall as positive, and it bounced back in an opposite direction of 11 meters per second. So that's the final velocity, which is 11 meters per second, and 11 is going to be negative now because it's going in an opposite direction against the wall, right? Now the question now, if you look at these two, there's a change in velocity. There's a velocity before and a velocity after. So this velocity before, it has its momentum, and this velocity after, it has its momentum. So there are different momentums there due to different velocities. So it simply means that there will be a change in momentum as well. Let's look at the question. The question, it says calculate the change in momentum of the ball. Okay, calculating the change in momentum there, you can calculate the momentum separately or you can calculate in combination. But what I'll do in answering number one, I'll calculate the momentum separately. I'll say momentum initial is equal to mv initial, and I'll take um and I'll take the mass. The mass is 0.1 times what? 13. So 0.1 times 13, when you punch that in the calculator, let me punch it. It's 0.1 times 13. It's 1.3. It's 1.3. 1.3 what? Kg meter per second towards the wall. Okay, let's say the direction, it's towards the wall, right? And then the momentum final, when it bounces back here, it's mv final, and the mass is still 0.1 times, remember the velocity is what? Is negative, times negative 11. So 0.1 times negative 11, the answer here, it's going to be negative 1.1 kg meter per second. It simply means that it's 1.1 kg meter per second against the wall. Um, so the momentum's different now. Change in momentum, it will be momentum final minus momentum initial, and then the momentum final, it's the negative 1.1 minus the momentum initial, it's positive 1.3, and then the answer here, it's negative 2.4, and the 2.4 it's 2.4 kg meter per second. The negative means what? Against the wall, which is in the opposite direction. Now let's look at number two. Number two, it says use the vector diagram to illustrate this change. So we're going to use the vector diagram to illustrate the change in momentum. So what do we mean by that? We have to show the P initial, P final, and the change in momentum in the vector diagram. So let me use the black pen now. Always, guys, with the vector diagram, illustrating the above variables, which is the initial momentum, change in momentum, and the final. So we should start with, the what? With the initial momentum and change in momentum. You can start with any between the two, and then you draw the what, the P final. So you start with any between the two, the initial and the change, and then the last thing that you're going to draw is the change, is the final momentum. Let's start with the initial. Where's the initial? The initial momentum, it's 1.2 1.3 towards the wall, which is, it's going to the right. Here's 1.3. Let's say this is the 1.3 kg meter per second. And then now I'm going to draw the change. Now remember, I said you start with the initial and then the change, and then the change, it's negative 2.4. So the 2.4, it's going to the left against the wall. 2.4, let's say it's that. Okay, in that direction, this is the change in momentum, which is negative 2.4 kg meter per second. And then now we're going to draw the final. It's 1.1, and 1.1 is the difference. If you notice, it's the difference between 2.4 and 1.3. It's 1.1. And always, guys, when you draw your final, here, you draw it from the tail of the first vector to the head of the last vector. Right, this 1.1, you draw it from the tail of the first vector to the head of the last vector. Here's the tail of the first vector and head of the last vector. So you're going to draw it in this direction. It's going where? Against the wall, which is going to the left. So in this direction here, you draw in that direction. So this is the what? This is the P final. The P final, it's negative 1,1 kg meter per second. That's how you draw a vector diagram. Guys, as I've mentioned before, doesn't matter which one you started with between the initial and the change. You can start with the change. Okay, let's see when you start with the change. Let's use the change as red. Let's start with the change here. The change, do you see? I started with the change. The change, it's 2.4, right? And then we go to an initial. Guys, these vectors, they must be consecutive, which is they must follow one another. So now the following vector that I'm going to draw is the what? Is the initial. And the initial, it's what? I use the blue. And the initial, It was 1.3 towards the wall. 1.3 towards the wall. So the 1.3, I'll just end it here. I'll just end it here. So this is the initial. It's 1.3, and 1.3 is positive. It's going to the positive direction. And then the next thing, it's going to be the P final. Even here, the P final, the momentum final, you draw it from the tail of the first vector, which is from here, to the head of the last vector, still going to the left. And what is the color that I used? I used black. It's still going to the left. Do you see? So this is the P final. It's negative 1.1. It's the same. They going in the same direction. This is the same as this one when it comes to draw the vector diagram, right? Another example, an 8-gram bullet. Um, First thing, you need to change that into kilograms. An 8-gram bullet is fired from a rifle. Here's the bullet. A bullet passes through a 10 centimeter plank. Here's the 10 centimeter plank. This reduces the bullet's velocity from 400 meters per second. So this means that this is the initial velocity west. So west. So we'll say that direction is west, and then to 300 meters west. So this is the word. This is the final velocity west. So this bullet is going in the same direction, but it passes through a plank. Now it says the question. The first thing that we have to do, have to change this. We say 8 divided by 1000. It's going to be 0.008 kilograms, right? So yeah, that's the mass. Okay, now what we're going to do in the first question, A, it says calculate the bullet's initial momentum. So we have the mass, we have the initial velocity. So initial momentum is mv initial, and then we take the mass, it's 0.008 times 400. The initial momentum is 400, and then the answer is 3.2 what kg meters per second, and the answer is positive. Remember, we choose west as positive. We choose west is positive, but guys, this is not the westerly direction. But in my diagram, it shows that it goes in the westerly direction, but it's not west. And then so the answer is west since it's positive. And then B, it says calculate the bullet's final momentum. The bullet's final momentum, so we take the mass and we times by the final velocity, which is 300. So when we times by 300, the answer there, it will be we say 0.008 times by 300. The answer is it's 2.4 kg meters per second, and it's still going in the westerly direction because the final velocity, it's going in the same direction. Remember what I said, if the momentum will follow the direction of the velocity. So C, it says calculate bullets change momentum. So the change in momentum, it's momentum final minus momentum initial. What is the momentum final? It's 2.4. 2.4 minus the initial, it's 3.2. And then minus 3.2. When you punch it in the calculator, you have negative 0.8. And then there's negative means it's 0.8 kg meters per second in an easterly direction, east. Now D, it says draw a label vector diagram to illustrate the bullet's initial, final, and change in momentum vectors. So this is D. Remember what I told you in the previous example. You start with the initial. You start to draw the initial. The initial is 3.2. Let's say this is 3.2. This is initial. It's 3.2. Okay, let me not draw in that way because it's going to the west. The west is in that direction. So it's a P initial. It's west. It's 3.2 kg meter per second. Right, we chose west as positive. Um, and then we draw the change. Then after we drawing the initial, we draw the change. The change is 0.8 and it's 0.8 west. So the 0.8, let me use another pen. The 0.8, let's say it's like this. This is the change, which is the 0.8. And then finally we draw the final. The final, it's 2.4 that is going to the west, and then you draw from the tail of the first vector to the head of the last vector. So it's going to be like that, which is 2.4, and the 2.4 is the P final. It's 2.4. Right, that's how you draw the vector diagram of that.